Lesson 27, the binomial probability distribution. Example 3. What do you see when you look at the following image? These types of images are used to test color blindness in individuals. So if you can see the figure of a red colored 8 inside of this green circle, good news, you're not colorblind. But if you can't determine that there's a red figure 8 within this green circle, then you might be colorblind. Color blindness, or more precisely, color vision deficiency, is the inability of an individual to distinguish the differences between certain colors. This condition results from the absence of color-sensing pigments in the cone cells of the retina. Color blindness is a sex-linked trait. That is, the genes that code for these color-sensing pigments are located on the X chromosome, which is one of the sex chromosomes. Individuals that are not colorblind possess a working form of these photosensing genes. We'll denote this with a capital X. When a mutation occurs in these genes, the color-sensing pigments cannot be produced. We'll denote this with a lowercase x. So, if a non-colorblind father, which is a capital XY, and a carrier mother, capital X lowercase x, were to have 3 children, find the probability that they would have no colorblind children. So here the question is, find the probability. And when trying to find the probability, we notice that this situation is focusing on this couple having colorblind or non-colorblind children. Thus, this follows a binomial random process, since a child is born either colorblind or not colorblind. That is, 2 possible outcomes. Thus, we can use the binomial probability distribution formula to answer this question. Now, to use the binomial probability distribution formula, we need to know the values of the 3 variables: the n, the p, and the x. Starting with n represents the total number of attempts. So the problem states that this couple were to have 3 children. So 3, the total number of children, would be the value of n. N equals 3. Next, p represents the probability that it results in any one of these outcomes every time they have a child. In this case, we're focusing on a colorblind child. So if a non-colorblind father, which has a genotype capital XY, and a carrier mother, which has a genotype capital X lowercase x, were to have children, every time they have a child, we'd get the following result. So the father has the capital X and the Y sex chromosomes, and the mother has the capital X mutated lowercase x sex chromosomes. Now the mother can pass on to her child either her working form of the X chromosome or her mutated form of the X chromosome to the child. The father can pass on either his working form of the X chromosome to the child, or he could pass on his Y chromosome. So looking just at the sex chromosomes in this case, we'll see that there are 4 possible children as the result of this couple having a child. And out of these 4 possible outcomes, all of them have a working form of the X chromosome except for one. This one here has the mutated X and no working form of the X, so this individual is colorblind. So P, the probability that this couple has a colorblind child every time they have a child, would equal 1 chance out of 4, which is 0.25 decimal or 25%. So being that the calculator is a decimal machine, we'll prefer to enter in the value as the decimal 0.25. Now for x. X is the value of the random variable, which corresponds to the probability question that we're trying to answer. Here the question is, let's find the probability that they would have no colorblind children. So the value of the random variable x that corresponds to having no colorblind children would be the x equals 0. So now we could use the binomial probability distribution formula with these values of n, p, and x to get our result. Since the question is just the probability of no colorblind children, or the x equals 0, we would use the binome PDF command, because the binome PDF calculates the probability of equaling that one value only. So, on the TI-84 calculator, we could find the probability of having no colorblind children by executing the binome PDF command using n equals 3, comma, p equals 0.25, comma, and x equals 0. The binome PDF command is located in the distribution menu. We find that by going second, distr, and then arrow down till we find the binome PDF command. When we find it, we press enter to select. Then we type in the n first, 3, comma, p second, 0.25, comma, and the x last, 0. Close the parenthesis, press enter, and we find our probability result. Hence, the probability rounds off to 0.422. So there we have it. The probability is 0.422 decimal. So, if a non-colorblind father and a carrier mother were to have 3 children, the probability that they would have no colorblind children is 42.2%.